bread shed from the beginning. New job, I've already called it shed. What do I want to do? I want to draw out a new shed, probably back at the office in peace. So I'm going to go sketching. There's my point pilot. Typically these steels are 6 meters apart or 6 meter bays. So I'm going to start with a gable. I'm going to go 2 bays wide, 6 meters. Now I'm going to go back this way, 3 bays. Back 2. And close it up 3. So there's the shed. All levels at 0 at the moment. Now I want to do the apron. So I'm going to go move my start point to there. And we'll make the apron 12 meters wide. But this time, because it's a concrete yard, we want to fall the apron. So we're going to go minus 0.25. And before I accept that, if we pan round, you should be able to see it's just sloping down. Okay, so I'll have that. And then we'll keep this way. We'll keep that level, minus 250. And then we'll just close that up. So we'll go connect points. Quick pan round, flat shed base, and sloped apron. Okay, so that's our shed, but that is 0, 0. If we look in here, points list, and look at the coordinates, we started at 0, and the only levels we've got in are those minus figures for the apron. Okay, so offset that out 3 meters. That's it. Okay. And we could close that up as well. Points and lines. Connect points. That one, that one, that one, and that one. So now we've got an area to cut away to allow for like perimeter drainage and things. Okay. Now that's our blueprint. We can take that to any site and put that in to tie into the existing. How do we do that? I'll export that as shed DXF, and that'll do. Okay, that's that bit done. Now we land on site. So we'll go to different job, topo. So now we're in the real world and we've measured the site to get all these points. We can see that where we want to put this shed is flat and then it goes up. There's a bank behind. Now, talking to Fred, he doesn't get the luxury of doing cut and fill. He has to place these sheds on sloping ground like this, and the customer's always got a point where they want to tie in, which I've called that little blue cross, and then orientate the shed using an existing building, an existing fence line. So I've put another cross in there for orientation. But that's basically it. Turn up to site, figure out where this building's going and where we need to tie into. Then, once you've done your topo, you can bring in, or you can create a surface out of it. So there's the surface of the existing ground. Okay, what do we want to do next? We want to merge the data that we saved from the blueprint, because that was at 0, 0, and then just a minus number for the apron. So first up, what we need to do is bring in that DXF that we saved. Now we're in the real world. We need to bring that DXF in, so I'll go import what do we want to do? We're going to bring in reference data from the internal memory. So if I look through here, I should have shed. There it is. So now we've got some data at 0, 0, 0, which should be our shed. And then we've got us all the way up here, if I zoom extents, in the real world. There we are. So now I want to merge this data. Very important that we disable scaling, and I'll show you why as we carry on. And we want to merge the shed. So now we pick what we need to use to tie this into the existing ground, and that is the front of the apron, because that needs to tie into the yard. So I'll hit 12. And then something for orientation, so we'll just use the back of the shed. 3. Okay, first step. So that's the blueprint, that's the drawing that was at 0, 0. Next up, select 2 points to define the transformation. So we need to go to the real world, or if we were on site, we could have literally just measured this tie-in point, like the existing yard, with our total station or rover. So there's my tie-in, number 1. So that's my base point. And then it's saying, next up, we want the second one for orientation. So that's number 2. Now the levels will come off the first one, so that's where my tie-in is. So the bottom of that apron that we designed, with that fall, that's where it's going to meet. Tick. Call it Fred Shed. Tick. Let's go to checks. Let's turn off that surface so we can see what's going on. Perfect. So there's our shed inside that topo. And if we pan around, we can see our problem. So the back of the build is cutting into this bank, and then everything else is kind of hovering slightly above OGL and then dropping down and cutting in for the apron to tie into the existing yard. So Fred's biggest problem is working out how much material that's going to need to shift. But it's really easy in here. All we need to do now is create a surface out of the shed. So if we clear some of this up, let's get rid of the topo. Yeah, turn those off. Right, volumes, surfaces, new surface, and we'll create a boundary around this. There's our boundary, and we can select other points as well. So there's not many more to do, so I'll just do it manually. Alright, I'm also going to put a break line across there where the apron tilts away from the shed. So I'll go here, do that. Tick. Fred Shed TRM. And there it is, all one level, falling away. Okay, so now if we bring in our OGL surface as well, now we've got this going on. We've got what we want to build, and we've got the existing. What we want to build is at finished floor level at the moment. That's important to remember. So if we go Toolbox, General, Calculate Volume, Surface to Surface. Now existing surface will actually be OGL, or original ground level. Design surface will be Fred's shed. Now, that's what we need to cut and fill to create that. So that cut is the bank at the back, that fill is where the yard comes over the OGL. But remember, this is finished floor level. So to get to formation, we need to apply, I think it was 150 mil of concrete, 300 mil of stone. So altogether, our construction thickness is 0.45 minus. I'm offsetting that design surface down now to give us that. That's our number. That is 327.5 cube to come out.